For this topic, statistic. Okay, so this one is an extension of whatever you learn in Sec 1. So in Sec 1, you have learned something on the pictogram, bar chart, pie charts, and line chart. So you can use a 4 example to revisit. So we are going to add on to the things that you learn in Sec 1. So we're going to add on with something called the dot diagram. And we're going to add on something with stem and leaf and histogram. Histogram is not exactly new to all of you. So there's a difference between histogram and bar chart. Okay, so bar chart is, there's usually a gap between the bar chart. So histogram, there's no gap. So sometimes some people misinterpret, they kind of mix up histogram and bar charts, but they are actually different. Okay, so I'm going to introduce you these three new things that we're going to add on. So I'm showing you the idea of dot diagram first. So as the name suggests, right, we use dots to represent data. So for example, in this question, example 5, the dot diagram represents the number of smartphones apps each of the 20 students downloaded last month. So you make it a point to read what is the data here. So here we're interested in the number of apps that each of the 20 students download. So the 20 students are translated to 20 dots. So for example, there's one student who didn't download any apps. Okay, and then there's one student who download like 28 apps. Okay, and then another one student here who downloaded 15 apps. Then here, this is 12. So you can count how many students downloaded 12 apps. So that's how we interpret data, the dot diagram. So essentially, one dot is one student in this situation. And you should be able to read off like how many students download how many apps. Okay, so in this question, for the first part, the most common apps, that means right, is like the most popular number of apps. Okay, the most popular will be 12 because there's a lot of students who downloaded 12 apps. So that's the most common number of apps that's downloaded. Okay, now when you answer the next part, we are going to answer percentage of students. So it can come under percentage, it can come under fraction, but you got to interpret carefully. So if you read the percentage of students who downloaded not more than 10 apps, it's a bit of English. That means it's 10 apps or less. So it's 10 apps or less. So that means 10 is included as well. So these are the 4 students who didn't download not more than 10 apps. So in this case, right, the percentage here will be 4 out of 20 times 100%. So 4 out of 20, that is a 20%. Okay, so sometimes you got to read the question. Okay, the next one, we need to describe the distribution. So usually when we want to describe the distribution, what are we describing? So we are trying to describe the range. That means the biggest to the lowest. So that can be one way. So the number of apps range from the number of apps downloaded range from 0 to 28. And we realize that there's a cluster here. Cluster means it's like there's a lot of people overcrowding there. Okay, so then the clusters are from 8 to 15 apps. So if there's cluster, we will mention the cluster. maybe there can be more than one cluster. That's quite possible. And then, right, these are what we'll call the extreme values. So the extreme values are 0 are 0, 27, and 28. So extreme values are like there's one of the sometimes we also call it like outliers. So it's a bit like sometimes when you have a class test, so everybody seems to be scoring around 50 plus 60, and then there's this one guy who scored like 100 marks. Okay, so he's very far away from the rest of the people. Or there's one person who scores single digit like 5 marks. So these are the extreme values. So when we try to describe data, right, we can describe the biggest, and the smallest. We can describe about cluster. We can describe about extreme values. Okay, so you got to see for yourself. Okay, so this is the interpretation of dot diagram. So another way will be they will give you a sample, then you're supposed to draw out a dot diagram. So this one needs some skills. You need to observe the data. So the first observation will be you got to count the number of data. So there are 16 data here. 16 data means there are 16 people. So I'm expecting 16 dots. And in order to construct the dot diagram, obviously you need to know the smallest and the biggest. So I think the smallest is 15. The biggest looks like 29. So you always need to ask yourself, what is the smallest data? What's the biggest data? So why do we need to do that? Because I need to have a proper scale first. So I need to have a proper scale like the previous one. Can you see it's from 0, 5? There's a regular interval. So I also need a regular interval. So the smallest is 15. So it can be like 15, okay. Then 20, 25, 30. So I think that should be enough. Then in between is 16, 17, 18, 19, 21, 22, 23, 24. Okay, you should be using ruler to measure. It's like your primary school, draw models. Okay, so make sure you use ruler to measure. Okay, so try not to have something like this is 15, then like this is 20, and then like this is 25. It's obviously like, the interval doesn't match. Okay, so you might get marked down for this kind of unequal scaling. Okay, then after you decide the scale, you need to put in the dots. So we're not going to count the dots and then put it in. We're going to dot one by one. Okay, so this is how we dot, like 23. So I should put one dot on 23. The dots, right, needs to be evenly spread out. If you see, okay, the interval is like very regular. So versus something like this, you cannot have something like this. Sometimes the interval is big, sometimes the interval is small. Okay, so you put one dot on 23, you strike off another dot on 21. So all the first dots should be on the same line. Okay, so it should be like on the same line. Then 20, there's also a dot. 16, there's a dot. 22, there's a dot. So you realize all my first dot are on a straight line. So 23, there's one more dot. 15, here, one dot. 29, one dot. 28, one dot. 21, one more dot. So make sure your second dot are in line. And then 23, one dot. 22 dot. Then 23, one more dot. 24, one dot here. and a double 21. So you make sure that there are 16 dots because there are 16 data. So write down the total number of students. So the total number of students will be 16 students. Okay, so for part 3, there is a probability concept. So if you didn't learn probability, you can think about doing it as a percentage. So for those of you who you learn probability, you can do it in a probability way. So I'm just going to show you both ways. So if you never learn probability, you can think about finding the percentage that the student take 21 to 25 minutes. Okay, so if I'm doing it in terms of probability, I will be counting the number of students. So how many students between 21 to 25? So 21 is here all the way to 25. So you count the number of dots. 11 dots. So for those who already learn probability, it will be 11 over 16. That's a probability. For those who didn't learn probability, you can think of it like a percentage, or you can think of it like fraction. What is the fraction of students that took between 21 to 25 minutes to complete the survey? So if I do the fraction, it will be 11 over 16. So if I do the percentage, it will be 11 over 16 times 100%. So actually probability is like fraction or like percentage idea. Okay, so that is the idea of dot diagram. So you must learn to interpret a dot diagram. You must also learn to construct a given data on a dot diagram.